Hello, everyone, and welcome to this Mobile World Live webinar. I'm Martha DeGrasse, and I'm delighted to be your moderator for today's event. Today's webinar is brought to you with our partner, Mavenir, and our topic is private networks, delivering on the 5G dream. I'd like to introduce you to our panel of experts. First up, we have Christian Massim, Managing Director, Center Connected Industry, RWTH Aachen Campus. Christian, thank you so much for being here today.
Pleasure to be here.
Next up, we have Aniruddho Basu, SVP and GM for Engineering Business at Mavenir. Aniruddho goes by Ani. Ani, thank you so much for being here today.
Pleasure to be here. Thanks for your attention and looking forward to the session.
We do have a lot of registrants here who are also looking forward to it. We also are lucky to be joined by Stefano Cantarelli, CMO at Mavenir. Stefano, thank you very much for being here.
Martha, you're very welcome. I'm looking forward to this, and I hope people will enjoy it.
They will. And our analyst today is Peter Jarek, Head of GSMA Intelligence. Peter, thank you very much for being here.
Hey. Hi, everyone. Thanks, Martha.
So as I mentioned, we have had a large number of registrants for this webinar, and we have gone through the questions that many of you asked in advance and hope to answer some of those today. If you would like to submit an additional question in the webinar chat box, please feel free to do so. And even if we don't get to that today, the panelists will be able to see your question and your email address at a later time. A replay of the webinar will also be available within the next 24 hours at mobileworldlive.com. And with that, I am going to hand it over to Peter to start us off.
Great. Thank you, Martha. We've been looking a lot at the topic of private networks at GSMA Intelligence. And, I've titled sort of my beginning as the most important topic in wireless, the question mark, in part because obviously we're here to talk about private networks today, but in part because, when we look at private wireless and private networks, what we see is that, it is probably one of the most important topics, not just because it's something that every operator is thinking about, because non-operators are looking at, but because it is a topic that touches so many parts of what's going on in wireless, whether that's 4G versus 5G, whether that's Open RAN, whether that's virtual RAN, whether that's enterprise digital transformation. It's such an important topic that touches on so many key aspects that you can group so much of what's going on in the industry under it, which is why it really is one of the most important topics to us. So with that, let me just go on to the next slide. Briefly, for those of you who don't know who GSMA Intelligence is, we are the research and consulting arm of the GSMA. It means that it's my team's job to deliver and develop research, insights, data that captures what's going on in the mobile industry, helps with product launches, service launches, strategy development. If you're a customer, thank you very much. If not, and you want to learn more, please reach out, but I won't dwell on that. So let's move on to the next slide. I want to start with a little bit of a level setting here. When we talk about private networks, when we talk about private wireless, sometimes people view it as just one thing. And I think it's important to note here that in reality, private wireless is it's a variety of options. I think of the word spectrum, but obviously spectrum has a different meaning here. It's a myriad of different options because there's different needs for what we're trying to do with private wireless. On the one hand, there's clearly a very purpose-built public network. And then on the other end, you've got sort of standalone private network, not leveraging operator spectrum. It's an isolated network. The enterprise owns that, has control. But in the middle, there's also the different options. Public network where you layer SLAs, slicing over the public network, which allows you to use that public network to deliver some key capabilities for the enterprise, potentially with edge computing, then thinking about some level of local infrastructure in tandem with that public network, or a standalone private network with operator spectrum. It's important to recognize that when we talk about private wireless, we're not just talking about one thing, because different enterprises have different needs, and we'll need to think about those needs as we think about what we're talking about from a private wireless perspective. It's also important to recognize, though, that private wireless, it's not just one thing in terms of how we're thinking about what's taking place in terms of the marketing messages that are out there. So if we look at what's going out there, and we talk to operators all the time, and when we look at what's going on in terms of how operators are delivering their marketing messages out to the enterprise, and we all know that the enterprise is the key market that most operators believe will deliver them added revenues in the 5G era. What do we see? Well, we see there's a lot of different things that are part of that marketing message. Private wireless is just one of those. It goes alongside of things like splicing, like edge compute that we talked about, like higher data speeds, of course. And it's important to recognize that right now, it's just one of many messages, and not the primary message of that. So the question is, though, does that make sense? Right? Where, from an operator perspective, should this fit into all of the other stories they're telling? Well, we went out and talked to operators then and said, okay, we understand how you're marketing to the enterprise, but particularly in terms of things like IoT. And as a level set here, IoT really is what we're talking when we're thinking about enterprise digital transformation. What are the technologies that are most important for you to be successful? When you're thinking about your success, what technologies do you need to be able to deliver to ensure that success in the enterprise? And here we find it's interesting. You look back at what we saw, perhaps in terms of edge, perhaps in terms of network slicing and how those sort of fit into the marketing message, talking to the enterprise. But when you ask the operator, you ask them, sort of, what is most important to you to be successful in the enterprise? What do you find? You find they think private wireless is more important than edge. It's more important than network slicing. Now I'll go back. From that first slide, you'll remember what I was saying was that, yes, private wireless is many different things, but from an operator perspective, they clearly understand that private wireless across different verticals is the most important technology, or marginally more important than edge computing and network slicing, to be successful in the enterprise. Again, that is pivotal to their 5G plans. Now, of course, this wouldn't necessarily make sense unless there was money out there. And I think I want to end on this before we get into the further discussions here. I think the final reason why it's important to recognize that this, for operators, private wireless is key for them. Private wireless is a technology they see as important. It's because when we go out and you talk to them and you talk to the enterprises and say, hey, are you willing to invest in this? You think you may need it, but are you willing to invest in private wireless? Well, what do you find out? Here again, across verticals, you see that enterprises across the board are willing to invest in this. They see the value as well. So I think it's important here, just to wrap up, that what we're talking about is, yes, private wireless, we can't just think about it as one size fits all. May not be the most front and center message that you're seeing from operators today in terms of how they're pitching 5G to the enterprise. But operators across the board recognize that it's critical to them being successful. And in part that works because they see, when they go out to the enterprises, verticals. Every single vertical sees that where they have coverage requirements that really require some level of localized coverage, those enterprises are willing to invest in private wireless. So with that, I want to say thank you very much. I'm glad, it's exciting to sort of kick off the conversation here. But with that, let me hand it over to Christian. Christian, it's over to you.
Yeah, thank you very much, Peter. Because I can just confirm these findings also from our point of view. In the center-connected industry, we have a lot of industrial users, meet a lot of them on the international level, who are just thinking about the private wireless implementation, later on integration as well. And that's basically what you will find there as well. Why does it make sense? Might it even be the all-you-need solution? Just a little bit provocative question to start with. To drive industrial digitization forward from the user point of view. And I have the pleasure to give you a small glimpse and an overview into what we found out so far and what our daily business and talk within the community is telling us. So what you will find where they start talking about, it might not be the 5G. Since we are talking about digitization, it's rather about what is that about? Where do you start? And usually each journey, if we now go to manufacturing, if we go to logistics, whatever level of industry we're talking about, we talk about visibility first. And how to create these all present digital twins we are all craving for to reap the benefits. It starts with connecting the shop floor, your assets, the operational technology you have, the machines, the forklifts, everything running there, and also all the additional sensor systems coming into play. The first challenge for all networks, how to cater for with all the new systems components in a heterogeneous landscape already, to reap really the information benefits of transparency, later on productivity with real-time simulation, models, recommendation, and so on, until we have fully automated and learning systems themselves based on reliable real-life data streams. We're basing it all on. And what's the situation we find nowadays when we come to a typical shop floor, talking to the head of IT, to the head of production. You find a lot of industrial networks on the shop floor. One still quite predominant, very often is the DECT standard, just for the audio calling functionality. It might not be that any worker on the shop floor has it, but quite a lot of them. And that's usually how you have your voice connection within the premises on the process line. Then that's still omnipresent. It's Wi-Fi, Wi-Fi 5 in that regard. If you already have mobile or wireless connectivity, most likely it will be Wi-Fi, the 5th generation in that regard. For connecting maybe already some tablet devices and maybe some of the machinery which is not mission critical usually. In some considerations, you might also have localization systems on-site or on premises, if it's a larger factory array, for example, just to give you positioning information of your assets so that you can better follow them, do a fleet management or other things like that. And of course, nonetheless, the biggest backbone would be still the normal LAN Ethernet connection you find with industry bus systems still at the moment. But the interesting part is how that's going to change in the end. Because what don't we have when not only a bigger hassle for the IT department in maintaining several networks at the same time, which have to interconnect at certain points and with a system landscape you are running, but might be also with a provider you have there. So you have usually no continuous information flow you can work with. It's also way more tricky to have basically also a uniform way of data processing, with more and more data streams being connected to it and relying on it in a crucial matter. And especially when we talk about real-time capabilities. Because in earlier times in industry, and some it might still be that, real-time would be fine to be measured in hours or shifts. But the closer we go in the digitization industry 4.0, or however to name it, we are going to the seconds, we are going to the milliseconds range. If it's safety applications we are running, or in the range where we call ultra reliable latency cases, you are really in the low milliseconds, 5 milliseconds or something like that, where you have to operate. So while talking to all of them, what do we find? What do they actually want? And they want it at least tomorrow as the backbone of the whole infrastructure, but quite some of them say already, yeah, best would be now. And that's quite simple. For these cases, it's reliability, always first position for a network, because basically you're putting all your stakes on it, on your processes, on your reputation, and so on, that you deliver in time and everything. Of course, it should be secure with all your trade secrets, process secrets within, and it should be potent to handle everything what you have now and also what is coming. So potency or scalability is a big thing to handle a huge variety of industrial use cases. I would say, just confirming what Peter was presenting us, that we're aware of a need for private networks as a backbone for the infrastructure, and also to run the services they're craving for, like the network slicing, for example, to provide a basis for the different use cases with all of their requirements. And that brings up always a big question we're also following up on here in different use cases with Mavenir and the other partners. What you see is, what is real-life implication of different technologies? Could Wi-Fi handle it? When here you just see an overview where we measure, for example, real-life view of an AGV running through the factory for material transport. And on the right side, you see the latency times, the real latency times while in transport, how much they vary with a Wi-Fi network, and how closely guarded and within the limits of the LTE, or when we switch it, the 5G private network stays always within its boundaries. So quite a critical component to consider for many use cases at the moment. Because while really trying to close the gap, as mentioned before, between the operation and technology with everything belonging with it, since thinking about connected industry, we're really thinking about connecting all of it, what you have. Every business object which might be involved in the processes will be connected in the future. And the earlier the better for most companies even, to create this level of transparency they need to still further optimize processes which are otherwise highly optimized already and can't go much further. And that all always aligned with the business application systems on the other side. And the question is, who can fill in, who can close that gap to actually provide that, to run then also the latest applications, which might also need a lot of processing power to later on simplify it and rely the necessary information or decision even to individual systems, to individual users on site, not at terminals anymore, but wherever within the factory premises, outside of it, maybe still while lying on the beach in the due holiday you have, still being able to access critical information if necessary. So where it could run on are the core services of a network, which could play a role in providing all the basic functionality you need to run it in a secure way and to provide it wherever it's needed. Have to figure out also from the radio side how to connect, how to cover also every use case in the best way possible and also how necessary. That you always have the bandwidth, the latency you really require for them wherever. And still make use of the power of edge computing, because most data processing from our point of view of factory data will take place there if it's not already handled or pre-filtered on the device level, because more data will be always available. You have to filter it however powerful the network is already there. But since latency is quite often critical, the edge computing will take a decisive role, providing the services with the power of the cloud directly on the shop floor. And the important part is then how to combine it all and bring it in the real life applications in indoor, outdoor scenarios, in campus networks, for example, when private and public go together. That will be the decisive question, how to bring it, how to implement it. And as mentioned before, it always starts with basically enabling the physical object to communicate what it senses to the rest of the world, to start actions, to have an interaction with the head user of that application, of that machine in the right way, providing it with the condition data, positioning data it needs, and all the necessary interfaces, so that the information can be actually transmitted to the right user, to the right system at all times. And yeah, very important with that, always the point of security. I think everyone is well aware of a triangle of 5G with all the key capabilities it provides. So what we still see is a lot of use cases starting with high bandwidth are the ones where you have to basically analyze and process image data, video data, real life data streams, because it's also kind of the oldest industry sensor system you have already in place, camera systems, usually just for security, maybe some also in connection with documentation, but now they will play an even more crucial role. They will enable object tracking and so on. Then the low latencies might not be required in all the use cases we are talking about when we talk about private network usage. But when you go to the technologies most are looking forward to still improve the already optimized processes, to further automate them, with autonomous guided vehicles, for example, that's already something you can't get around, especially in safety-bound areas, or if you run a lot of them in the fleet and they have to then react to each other in the most efficient way. And of course, whenever you have a more natural interaction with someone on the shop floor or on a remote location via AR with a big amount of data, but also latency, so that it feels basically like you're on site, require these kind of low rates in the milliseconds. And what will, from our point of view, follow a little bit later is basically the scalability we see in it, with a massive uptake of connected devices on the lower end, but also on the higher end in that regard. When we talk about logistics, then all the crates in the factory, all the goods might be able to be tracked with their condition. That might be already a late scenario, but starting with a whole fleet of vehicles you're using, the forklifts, the AGVs, also the trucks which are coming on site, and so on. They will require a lot of capability in that regard to handle all of these streams reliably. Can't stress that one enough. And here just a few example use cases I brought with me, we are working on together, just to give you an idea where they're all situated. So as mentioned before, when we talk about visibility, everything at the moment starts basically with condition monitoring to create this all-powerful digital twin of our production and logistics processes. How do you connect everything which has already a connection, like AGVs might be able to have it already since they're quite new technology, but you also have to take in consideration the huge chunk and amount you have actually, which is not on the green meadow. So it's way more than 95% of machinery and everything is not connected, or not connected in the way that the sensor systems you would actually need for nowadays or next level operation coming within the years now. So the question is how to connect them, how to get the data out of there, and how to handle it. Because that's already the first step you have then of data processing. The anomalies are detected as early as possible so that you maybe can still handle it in line before you have later on to fix a certain good or problem. Always costs more, always takes more attention afterwards. To have that automated and bring, for example, here's an example, the power of audio recognition to the table, just by sound analysis, figuring out if there's a problem with machine, with your robot at the moment, and can fix it in time, or know exactly what it is doing at the moment to follow it. When we go to other cases we see where it might be even more crucial than we thought at the beginning, is in flexible layouts you see more and more, since we're looking for more individual products and also shrinking lot sizes, going towards one, if you could have it. And best of all, to have it in no time delivered to us as well, as soon as we have configured it on the business, but also on the normal consumer side. So that requires that assembly lines, manufacturing lines are highly flexible by now. Also logistics centers, they're constantly changing. And I can just tell you what kind of headache it always causes to everyone to do the cabling of that. And power cabling seems to be never a big issue, never a problem, wherever you talk. But to have a network connectivity, if it's still cable-based, no one likes to think about it in terms of time it takes or costs it actually causes. So that might be one of the big starting cases as well, just to have everything wireless because you have to change so often. And as I mentioned beforehand already, the robot control, also remote control, might it be in the fixed installation lines, might be also to be more flexible there, as we see it, more and more upcoming, that you use it where it's needed and don't have a high expenditure directly at all stations, but you can use it flexibly and bring it to the station where it could bring the biggest benefit at the time. Also, just in the line of flexibility. I was talking about beforehand when we go into the ultra reliable and ultra low latency cases. How does it look like with safety? We have more and more automated systems on the shop floor. It's usually not a lights out factory or anything we won't see in the near future. And so you still have the shop workers. And how do you make sure that worker safety, work safety is always a given? Even when these automated vehicles are coming to a crossing point at the moment, they're safe, also sufficiently safe, but they have to stop. Or they drive way slower than they could because they can't determine in real time the whole situation here, for example, of a crossing, and if someone might be coming or not. Because if no one is coming, the easiest part would be just to give basically that event, for example, to this autonomous guided vehicle there as a transport, giving it the chance to drive full speed. Because at the moment they go with pedestrian speed just due to safety reasons, always. And if they could go 2, 3, even 4 times faster if they're allowed to. If you can do that reliably, you can just imagine the boost in efficiency we can reap out of it. And even thinking further in the line of processing of information would be when we use the information they usually generate, all the data from the LiDARs they are infused with, also the stereoscopic camera systems, they just use for navigation from point A to B to be able to process in real time when they see certain pallets, certain components which are needed maybe someplace else in the factory, in the workflow, which were beforehand always looked after, and someone had to run for the factory, for the whole site, just to find it again and bring it to the right spot. And with that, you have continuous inventory, for example, and never lose anything anymore. So it's all possible, and we are very much looking forward to it. Also, bigger transitions on the whole supply chain, because that can really create this overall connectivity, that you have it on site with your private network, then with the transition to the public network, still running the same secured services, which should transition in the next private or campus site, providing you with seamless flow of information, like in that example where we did it for the head of production in a supply line. You always know when your components arrive. That's good to know. If there is some delay, you can automatically, with help of AI, rearrange your production order. And that all in real time, huge boost of productivity in that field, and huge need for cooperation also in handling these network transactions. Maybe just a last example. We talked about it could replace as a one solution for all, also positioning in the future. As we know, that's going to arrive with release 17 of 5G. Also in the range of meters, maybe below. In terms of resolution, that would be great for a lot of applications. But if it doesn't work, we can help ourselves. Since we have mobile devices, which are also equipped with camera systems and also localization on their own. In combination, you can have something like the assisted GPS, so that your mobile network could provide basically a basis, a rough estimation of a localization, even now already, and just with the help of always preloaded image data from around you, you can home in on even the smallest switch you have on a machine or the relay you have to work on with high precision. But all requires a reliable network, high bandwidth, and edge processing always behind it. And we think with all of that, the innovative ideas everyone is following up on in industry, with Industry 4.0 and so on, can be fast go into prototyping, also a requirement for most parties. We know in industry, maybe not the biggest companies in the world, but at least when you go to the SME range, for sure, that they have to test it. They want to see it on site. Does it also work with me? Because everyone thinks he has an exemption, why it shouldn't. And the more standardized or the more easy you can interconnect all the components which are needed from this ecosystem we're talking about, the sensors, the network, and so on. You can provide industry pilots in lower and lower time frames and create productive use from the very start. And this is just continuing and continuing since the processes are self-learning and should optimize continuously. So just from our point of view, we can say this idea, this vision of connected digitization is not far off anymore, and definitely no rocket science. And that we can just encourage everyone there to think big, but start small to get running, get connected, not only in a technical term, but also with partners. Think about the ecosystem you have to work with, you can learn from, and drive a solution fast and scale it fast for full operation. So that's just as a small outlook from our side. And I'm happy to hand it over to Ani and Stefano, who tell us more about the special aspects of private networks, the why, the what, the how.
Thank you, Christian. I'll just take maybe 5 seconds for a quick sound check. Martha, if you can let me know if I'm audible in the chat box, then we'll get cracking.
Yeah,
seems like it's all
fine.
Wonderful, thanks. Good day to everyone. Pleasure to have all of you here. Looking forward to the discussions. What we're going to talk about today, as you heard, is a little bit of the why, what, and how. Shout out to Peter, he spoke about the industry context and the trends. Shout out to Christian, he explained the use cases that private networks will enable. Stefano and I, we will walk you through a little bit more of the what and the how. Having said that, I'm Aniruddho Basu or Ani. I head up emerging business and private networks at Mavenir. Stefano, my colleague, he's the chief marketing officer, and together what we'll talk about today is first starting with why. So 44 zettabytes is a very big number. That's 44 followed by 21 zeros. That's actually the size of the digital universe in the year 2020. All the little bits and bytes of data that are in transit, in storage, across devices, across sensors, across storage mechanisms, that's an enormous volume of data. Now, why is that important? To just put things in context, 44 zettabytes and this 44 followed by 21 zeros, if you add 3 zeros to that, after you get to a yottabyte and then you run out of the decimal system. Now, why is this number so critical? The number is critical because it defines the fact that all of the businesses, all kinds of industries, all kinds of enterprises, all sorts of consumers are fundamentally basing their next journey in their evolution towards being more digitally connected, the entire transformation that they're doing in terms of their businesses and their processes will be data-centric and mobility-centric. Over the last 20, 30 years, most of the mobile networks, they've served consumers and enterprise light applications. You've got more than 7 billion mobile subscriptions today, more than 5 billion smartphones, but fundamentally a very consumer-centric orientation. What's really critical and crucial now is that industries and enterprises have started to digitalize. They're going to be piggybacking off these 44 zettabytes and mobility to really transform themselves into the next generation of connected enterprises and businesses. So we are now going to transition from what is essentially a mass market need to much more specialized requirements that you heard Christian talk about, which are not really catered for by lowest common denominator kind of networks that are typically catered only for smartphones and consumer-centric use cases. The good news is that based on a homologated licensing spectrum regime and standardization over the last 3 to 4 decades, we have reached where we are today on the consumer side of things. But it has been restrictive in the sense that spectrum has been extremely regulated, it's been very expensive, auctions have happened, and that has kind of limited its adoption in the wider purview on the enterprise and industry side. There's been a much more pragmatic regulatory shift where we are seeing more and more countries, more and more policymakers coming out with specific spectrum allocations, thought processes, decisions, and essentially trying to implement either lightly licensed or sometimes even unlicensed spectrum capabilities that will truly unlock the possibility of cellular technologies and 3GPP technologies to be more broadly adopted in the industry and enterprise space. So far, telecoms and IT has been at a loggerhead, their way or our way. IT has evolved on its own horizontal innovation, decoupled innovation across multiple stacks. Telecoms has always taken about 1G every 10-year kind of approach, a very vertically integrated approach. But with 5G, with enterprise networks, what we are truly looking at is a world and networks where both telecoms and IT will converge, will implode, and create what you see is the next bullet, moving away from vertically integrated appliances, which have traditionally been very hardware-driven, to much more horizontal platforms that have adopted IT building practices that really focus on cloud, that really take in the capabilities from web-scale platforms and adopt that to enabling the next generation of connectivity and application development. Last but not the least, and this is quite critical, over the last 15 to 20 years, the technology landscape on the provider side has shrunk from somewhere around 12, 13 large companies to essentially less than 5 today. Historical players, big players, great players, but still just a handful of players. That is not good for the industry. That limits the amount of investment and R&D dollars that can be put in, that creates more oligopolies, that restricts competition, and that essentially slows the pace down for our industry. What we believe in, specifically for private networks and for 5G in general, is the need for more open ecosystems, back to basics, and finally, really, the democratization of networks. So if you get the why, I'm going to ask Stefano to kind of give us a flavor of what exactly are private networks. Are they new?
Yeah, thank you, Ani. I think, after what we have heard, a lot of the things that we are summarizing in these slides are actually you have already heard, but I think it's good to actually see them all in one slide. As we said before, private network is not just something new by itself. I mean, we had private networks in the past, and they have been there for many, many, many years. If we think of things like emergency network or police networks and things like that. So it's just exactly new that. What is really new is that there are some emerging needs that actually makes it particular. And if you look at the picture on the left-hand side, you'll see that one big thing is that the cyber physical system, mission critical, production critical, and I think out of what Christian has been saying, it was very clear that there is an opportunity to actually try to converge all the requirements into one infrastructure, which is much easier to support rather than having multiple means to do that, as well as the ability to tap on the capability of public networks, which actually have a large coverage into capabilities additional, which are needed, like in the NSPS or police stuff and so on. So the four big categories that we've seen in the new demand is guaranteed coverage, because of course you want to make sure that all the areas, even in geographically remote areas or indoor, in building as well. You want to have network control, which means that you wanted to apply configurations that not necessarily are supported in a traditional public network. You want performances, and that, of course, we have heard it very clearly out of Christian, and security. That remains an underlying and very important component. So here then, the what is what I think is a very interesting conversation from the point of view of the networking side, which is, we have really two models, and Peter has actually disaggregated into more than two, but the nature of it is really whether the networks, the private networks, will depend onto a public network MNO type of capabilities where the integration could be at different level, or they are totally independent, of course, with some form of optional connectivity to the public network. So, Ani, what do you think? Is this a good picture to get it to what is needed to implement this?
Thanks, Stefano. Spot on. Then that's a fantastic segue. If you take a look at the next chart, and I'll just urge the audience to kind of not really look upon this as a product pitch. That's not why we've intended to do that. But I'm going to try and tie in what you saw on the what and why to how we need to address the connectivity and the application enablement piece. This is essentially what we call is our MAV Edge portfolio. That's our private networks end-to-end solution stack. And essentially, from a logical construct, it has three broad layers. One that you see at the bottom is called the connectivity and the mobility stack, that essentially comprises all of the elements of a multi-access, multi-application, multi-capability, and multi-G radio access mechanisms with macro, WAN, indoor small cells, and what have you, and our Open RAN software. The second part is the heart and lungs of the system, which is a cloud core with the possibilities to break stuff out on the edge. That's essentially where we can do either on-prem or hybrid deployments or even cloud-based deployments, where you have the heart and lungs of the network, a slice-capable, cloud-enabled data core with voice extension services, if needed. On top of that, we've slapped essentially what's a very elegant automation layer, because we feel that the entire complexity around a sliceable 5G network needs to be fully automated in an enterprise and industry environment to make zero-touch provisioning, to make fast boot-up times possible. So that's essentially the connectivity and the mobility piece. But what essentially is extremely important is to enable industries and enterprises to be able to add, create, and augment value over the top. So the blue piece that you see that we call is the service enablement piece is what we call is our Mavenir digital enablement platform. And that essentially is the construct that allows us to create an application marketplace, exposes and abstracts the complexities of the underlying network, and enables us to therefore create what is the third layer, which is essentially the ecosystem layer of both third-party partner applications as well as Mavenir applications on top of the connectivity piece. If you take the next chart, Stefano, this one fleshes out back to what Peter had reflected upon. The constructs for private network adoption need to be how they are presented. They need to be fundamentally very simple. And this is a shout out or a call out to the entire industry, and especially from the telecom provider side. Keep things simple. In our side, what we've decided to do is three major focus areas. There's two types of hardware: access hardware or edge and data center hardware, and then there's full stack software. Very, very simple. The fourth element that we really focused on is when you're used to consuming things more as a construct or an outcome or as an IT license in an enterprise environment, it's not possible to have complex 250-page statements of compliance that we typically do in the MNO or the CSP side when we do very large build-outs. It needs to be simple pricing constructs, $1 per hardware or $1 per consumption or $1 per service. The next chart, this ties in that, and Peter also, again, back to what he mentioned, one size will not fit all. Different enterprises will have different deployment needs, different kinds of applications, different orientations. Some folks will want completely on-prem deployments because they're reluctant to pull data outside of the enterprise premise. Some folks, especially a long tail of enterprises, they're not very asset intensive. They want to consume the entire connectivity piece more as a service. There will be other folks that are looking at multi-location enterprises or edge breakouts where they would like to put and port applications on the edge appliance that will benefit from edge acceleration. So our idea and our solution stack, essentially, we really worked hard to make sure that we cater for all of these different deployment mechanisms. A small enterprise, for instance, 80% off-prem with just access points on-prem. A medium enterprise that is maybe 50% off-prem with some edge breakouts and the rest of the access points on-prem. A large enterprise, big options, maybe deciding to go completely on-prem, where we have tried to come up with an IT-based construct and an IT kind of guiding principle to building networks, slap in 2 servers, slap on a great GUI to manage the network, consume it as a service, make the underlying network very accessible, integrate third-party applications on the fly, and you're good to go. So this leads us to what should be for not just ourselves, but what should be the guiding blueprint for these kind of solutions. We feel that the guiding blueprint is that over a period of time, there needs to be great TCO compared to traditional network deployment models. It needs to be as much flexibility for all of these 3 different kind of environments that I spoke of. There needs to be a clear transparency in pricing. It needs to be understandable by IT departments, not just complicated telecom gearheads. Last but not the least, to be able to drive innovation and adoption around use cases, we need to drive service velocity from development into operations and adoption. And all of this needs to be built on top of things that are multi-G access, multi-access cores that can also embrace things like Wi-Fi, a very strong analytics and automation layer, this whole app store construct, and then coupled with really advanced services. Having done that, we started this journey about 18 months back from a concept sketch on the back of a napkin. Stefano, have you made any progress?
Well, actually, Ani, incredibly, I think considering that Mavenir is being relatively new to the enterprise market, we're actually being extremely successful. And I think the reason is not only our approach, but really the market is, there is such a big momentum. There is such a big request that the enterprises are really looking on how they can actually bring all these capabilities inside. You can see here some of the some of the deals that Mavenir has been striking with their partners. It's been a huge opportunity. We have to focus to make sure that we also deliver it, because of course, as these solutions requires initial focus to become to more industrialized delivery. But the momentum is huge, and we have seen the reason for it. And they span from across all the continents, so it's not specifically, geographically located to a specific area. We have seen across the whole world a very very strong interest. And to recap a bit what we just said here in the presentations, I think the Mav Edge solution for enterprises for Mavenir has been key, really, because it brought some of the strong points that are required. One is the ability to have an end-to-end solution for very fast time to market. Enterprises looking for very low footprint solutions versus situations where in the past in the telco they required a lot of integration. Integration had to be done immediately, and it had to enable a lot of multiple use cases. Some of the architectural complexity has to make it very simple, and we have seen different models that could be either on-prem or on public cloud with distribution of infrastructure, but always important to have automated installation, zero-touch provisioning, and a very good ability to analyze what's happening in the infrastructure. And last but not least, of course, the ability to have, as Ani has said, a very predictable model with a flexible business model such that you are able actually to understand what you're having and you utilize what you're buying in a very flexible and transparent way. Ani?
Thanks, Stefano. Spot on. I'll just bookend this last bit here. Some of the inflection points in the journey that telecoms and ICT has: early 90s, 1991, the first SMS, voice services. Then I think the last really truly deliberative moment came in 2006, 2007. That's about 15 years back, when the first iPhone was launched. Now, why is that important? That was important because it unlocked a completely new economy. Not because of the iPhone, but the fact that the underlying network suddenly became abstracted in its complexity. And then you had what is called as the App Store. There's people, enterprises, businesses that created value over the top. Our ambition as a company, our ambition with the Marvin solution is to have that App Store moment for enterprise and industry. What you see here is kind of our shining beacon, guiding light to kind of be the lighthouse for the industry to connect 1,000-fold kinds of devices on the left to any kind of applications and clouds on the right, with a cloud-capable, slice-driven, multi-access 5G or multi-G network in the middle, but most importantly, a network that's sentient, that's self-healing, that's intelligent, and last but not the least, and this is the most critical, that allows the development and creation of value over the top. Open APIs, open interfaces, and a collaborative and ecosystem approach to allow industries, enterprises, and people to create value over the top. Thank you very much for your attention, and over to you, Marta.
Thank you, Ani. Our first question is for Stefano. We've heard a great overview of the building blocks of private networks, but now let's take just a minute to get into the details of actually deploying a network from an enterprise perspective. Let's discuss the scenario in which an MNO is involved and brings the spectrum.
Yeah, thank you, Martha. This is the one where a lot of people have started with, also because you need to understand that operators, we all know the operators in the public environment for public services, they have been, having difficulties in the last years. Their revenues have been at the best and remaining flat. So really, what they're looking at opportunities to get a new revenue stream. So they have been starting to propose to enterprise solutions. And to be honest, this is a very interesting options where a lot of stuff already done. They are present in the network, and some of the capabilities of 5G will actually enable the enterprise capability completely. And even segregation, natural slicing will provide the quality of service, segregation geographically with deploying user plane remotely such that the data can remain secure within an enterprise. So in reality, this model is actually not to be discarded. It's actually a quite interesting one and could be fast. There is only one but, in my opinion, which is operator needs to get faster to the market. They need to get those infrastructures that allow them to be faster to market because, as we know, in the last years, they have been a bit slow in providing new services. And I guess the enterprise will not be willing to wait for that.
All right. I think you're right about that. Okay, let's talk about enterprise deployments on commercially available spectrum in different countries. What are some of the practical challenges here? This question is for Ani and Christian.
I can maybe start and then segue over to Christian. What we see is that there needs to be very clear regulatory policy that supports the adoption and encourages enterprise and industries to take them on. One very good example, and the outlier in this, has been Germany. So Germany, towards the end of, let's say, 2008, 2009, when LTE was just being deployed, the work around building 5G had started. So Europe, with a lot of leadership from Germany, said that they wanted 5G to be the G that was going to be the transformation engine for enterprise and industries to digitalize. So from that time onwards, landing up until last year, Germany has made available 100 megahertz of spectrum in the N78 band with an exclusive charter for enterprises and industries to pitch and bid for. And when I say pitch and bid for, they only need to pitch and bid for given what they will use the spectrum for. It's very nominal fees. It's about 10 to 15,000 euros for 10 years. But the idea is that they're actively encouraging enterprises on your own spectrum assets, make sure that you deploy these connectivity layers and drive private network adoption. We see a lot of similar initiatives happening, for instance, in Northeast Asia, countries like Japan, Korea. We are looking at stuff in Taiwan. Thailand is looking at millimeter wave. North America has had a little bit of an ambivalent approach. About a year and a half back, there was a lot of talk around adoption of 5G and CBRS. The awkward part there was there's a piece that is allocated out for PAL, there's a piece that's allocated out for GAA, and it becomes a bit difficult when one piece of this so-called private network spectrum is auctioned out for billions of dollars, which obviously for very clear reasons MNOs will try and monetize. And then you have 70, 80 megahertz or the balance 50%, which is likely licensed and available for any consumer or enterprise initiative to kind of take up. That, I think, this ambivalence has made the adoption of private networks with CBRS in North America a little bit of a laggard. But I see things aligning more and more going forward. So what we feel, and this is back to what Stefano mentioned and Peter had said, the jury's still out on whether it's going to be always an operator-led deployment or is it only going to be enterprise-led. It's going to be horses for courses. There will be a mix and match of licensed and operator-owned spectrum that will be brought into play simply because there's advantages to macrocellular roaming in wide area networks. But this needs to be augmented with widely licensed and relatively inexpensive spectrum that's made available for operational technology transformation for enterprises.
All right, great. Kristen, do you have anything to add?
Not that much, actually. It's a quite great summary. I can just strengthen it a little bit. You gave the example of Germany, Annie. There you can really see it, how it picked up when it was now made available with very cost-efficient spectrum, the possibility to access it. We first saw in the first few weeks after it was opened a handful of applications. I think most of them came from us even. And by now we are in the hundreds of it. And everyone really considering 5G in the industrial field is also thinking about getting such a spectrum license because it's that cost efficient for their side just to have it and think about later on how to implement it with a private game, with a maybe public-private campus game to have that running. And it seems to be the same discussion like we're still having with cloud or not in terms of running applications. There will be always some which they want to keep private. They should never go to the public sphere. So it will be a nice game changer to have that kind of spectrum availability across Europe and across the whole globe. It will widely boost the implementation of 5G applications.
All right, thank you. We have time for one more question. This one is for Peter. We heard in the presentations about the integration of telco equipment and connectivity with IT enterprise software and the cloud. So what's the likely relationship between CSPs and cloud players? Who's best positioned to address the enterprise private wireless need? Are they mutually exclusive or can they work together?
Yeah, it's a great question. It's I think on the minds of everyone. I would just come back to I think a bit of what we've heard throughout the day today. I think Annie hit it right when he talked about horses for courses, right? It's going to depend on the needs of any given deployment, any given enterprise. But let me just say, I think to this question of mutually exclusive, because that's the big one. Are they friends and enemies, and where do we see the cloud? I would just call out a few things. One, I would say, we're seeing this, right? Every day, every week, there's something in the news about a telco building a partnership with cloud players where one part is delivered by the telco, one part's delivered by the cloud player. We're seeing, the major vendors do this. I think it was just, we can look to, in fact, what Mavenir has done, right? Mavenir has work going on with Telefonica, or rather Telefonica has work going on with Mavenir and AWS and IoT. Why? Because, there are different pieces of those solutions that all fit together to actually deliver what someone needs in the enterprise. And ultimately, and I think it's important to recognize, the enterprises aren't going to be looking to piece these things together themselves. they're going to want solutions brought together, and those solutions will require components from the cloud as well as from the telco and from other vendors. And so I think that this idea of mutually exclusive is out there because it's, it makes for a nice press. There's a bit of a tension there of it's us or them, but I think we're already seeing in the market that this really is it really is a collaboration, and particularly a collaboration with a focus on what the enterprise needs.
Thank you very much, Peter. Well done answering a complicated question in a short amount of time. We are out of time, so I would like to thank all our guests very much. Christian, Aniruddho, Stefano, and Peter, thank you all very much. Great webinar. This will conclude our presentation for today.